All right, I'm recording. So what we are going to go over tonight. First, I think most everyone, since you're here, you realize that my course content will be in Canvas. I am not using Blackboard this semester. I hate Blackboard, and I'm really hoping Canvas is better. So I also don't know how to use Canvas yet. So I haven't figured out how to do assignments and quizzes and how to get my course content in there. Like, I haven't figured that out yet. So I'm working on that. So bear with me, please. But I know you can email me through there or just send me an email at my VCU email address. And I'm happy to help wherever I can. We are going to have 2 books for this semester. Let me grab them real quick. The Python Crash Course book. It's a very hands-on tutorial kind of thing. I really like it. And I think this is the other one. Python for Data Analysis. They're cheap on Amazon. You might be able to get them through VCU for free or cheap. I don't know. My other class, they can get the books for free, which is kind of awesome. But it's digital, and I hate digital books. That's because I'm old. But those are the 2 books we'll be using. My syllabus. I'm going to spend a lot of time on this. If you can read that, let me ambigify. All right. Let me make sure it's all on the recording as well. All right, that's good enough. All right, I am Chris Fauerbach. I have a full-time job. I work at Capital One. I am a senior distinguished engineer, which means I'm a senior director level, which is a fairly senior level at the company. But I am an individual contributor because so my job is to be a technologist. My job is not to manage people. And so everything we talk about is stuff that I know and I use regularly in the workplace. So I think because of that, there will be an extra level of why I think this is important for y'all as we go through it. We have synchronous virtual class. Synchronous meaning we will be meeting in person now, 7 o'clock Thursday nights. Like I said, I record things. I don't take attendance. I won't take attendance because y'all are seniors, juniors mostly. And so if you want to fail by not showing up, that's your problem, not mine. Right? And so I'm not going to take attendance. I'm not going to hound you if you're not in class. Well, maybe. If I notice a pattern, then I'll reach out and make sure you're okay. But your job is to be here, and my job is to teach. So hopefully you'll be here. And it's because of that, also, I have a pretty high expectation that you can figure things out yourself. That doesn't mean I'm not going to teach you everything I can. I am the most patient teacher in the world. If you are trying to learn, I will spend hours outside a classroom with you. I will reiterate topics over and over until you get it. But if you aren't trying to learn, if you don't care, then I'm not going to help you. And unfortunately, I'll say fortunately, the majority of the students at VCU I've taught care. The majority of students put in the effort, ask the questions, email at night because they're stuck on something. That's absolutely fine. The number of people who don't care are unfortunately there in a measurable number. But if you're not going to try, I'm not going to try for you. But if you try, I will go above and beyond all day long. Just know that. This is the first semester I am teaching this in Python. So my syllabus has an estimate on the first couple of weeks of what we're doing. Beyond that, I don't know what we're going to get to. And so bear with me, please. We will have course content every week. We will learn something new every week. But I can't promise what week we'll learn what topic. So again, bear with me, please. Please be patient. Prerequisites. I think this is a standard VCU prerequisite that you had to have taken Info 350 and gotten a C or above. And we'll do a lot of Python stuff. I'm not going to go through all what we're going to learn. Honor code is my absolute favorite and most hated topic here. The first time I had to send students to the Honor Council was in this class, and it broke my heart. Just to be kind of real with you guys, because I put a lot of work into this, and like I said, I go above and beyond to try to teach you guys stuff. And for some of those students in that class, they still decided to cheat. It's happened both times I've taught this class. So I have a zero tolerance policy on cheating. I don't know why you're going to cheat. Everything's open book. Because in notes and slides, when you do quizzes and tests, because you're at home, I couldn't stop you if I wanted to. And even in person, I wouldn't. So just we'll talk at length about what is allowed and what is not allowed. But if something is on the not allowed list, or if I say for this quiz it's closed book, please respect that. I got over the heartbreak part real quick once I realized, wait, it wasn't my problem, it wasn't my fault. They cheated, I didn't cheat, right? And so now I'm kind of heartless about that topic. So zero tolerance, don't cheat, please. You're only cheating yourself. You're going to lose a lot of money by getting a zero in this class if you cheat, get caught, and get submitted. And if I catch, you will be submitted. Okay, that's the negative part. We'll be using, okay, this I need to update. And I'm sorry if you spent hours trying to install Visual Studio Professional on your laptops, because we aren't using it, because it's a piece of crap software. We'll be using Visual Studio Code, and I need to update the syllabus. Visual Studio Code is from Microsoft. It's a very lightweight IDE. It's probably one of the best pieces of software they put out in the last 5 years. It's fantastic. So we'll be using Visual Studio Code primarily. But if you if you would prefer to use PyCharm, or if you'd prefer to use VI, I don't care really. But every class I'll use Visual Studio Code, and we'll go through how to use that tool for a lot of reasons. I have found that Anaconda is the easiest way for us all to have a consistent experience with Python. So that'll be the Python management tool that we'll be using throughout the class. And I know it works on Windows, Linux, Mac OS, etc. And that is kind of the extent of my syllabus. Does anybody have any questions before we dive into the really fun stuff? We're going to get right into it. So ask questions now if you got them. I'm going to need more interaction than this, y'all, over time. Chat questions. I can't see them because I'm recording. Can someone translate a chat question for me?
Do we need Windows 10 Pro to download Docker?
You need Windows 10 Education or Pro. Windows 10 Education you can get free from VCU as a license upgrade. That's another thing I have to correct on there. Great question. Docker is not going to be a large part of this class. It will make life easier later when we do start talking about connecting to databases and stuff, but it's not a huge part of the class. Let me reiterate. Please don't cheat. I will not hesitate to send you to the Honor Council, and you'll get a 0 in class. Okay, that's it. All right, Python. Everybody ready? I'm really ready for this. I've been waiting for this for like a year and a half. So Dr. Wynn was the department chair for a while. He just retired this summer. Good for him. I met the new department chair the other day, interim guy. I forget his name, Jeff something or other, but super cool guy. Anyway, Python is a much higher level of abstraction in computing compared to languages like C or C++. Which means you're going to write a lot less code to do the same thing. I had a really fun example for making an API call to Spotify to find like our Spotify playlist or something like that. And it was like 4 lines of Python code, but 400 lines of C++. It was ridiculous. And so we are going to get more into what you can do with the language instead of how to use the language itself, which I'm excited about. In industry, Python is used heavily for DevOps. If you're not familiar with the concept, it's developer operations. So the idea of taking code and building, testing, deploying, managing applications all automated. And so DevOps is heavily uses Python. data analysis, machine learning, where you're taking these really, really large sets of data and figuring out how to make sense of that data with a simple Python program. And just general computing. You can use Python for anything, just about anything you can use any other language for. If you can do it in C, you can do it in Python. If you can do it in Java, you can do it in Python. And it's a generalist language as well. And it's much easier to learn. We don't have to worry about pointers and what a pointer is and how we dereference memory and allocate memory space and all that stuff. We just learn how to do stuff. So what is Python? From the Python website, I'm not going to read all this. I will hit the highlights. It is an interpreted, which means it's not compiled, object-oriented, high-level programming language with dynamic semantics. We'll talk about this at length in a minute. High-level data structures, good for rapid application development. My favorite part in here is the glue language. I have made a career out of system integration, so making one piece of code talk to another piece of code. Python is a fantastic language for that. Simple, easy to learn syntax, modules and packages. There are open source packages for Python that will do everything you need to do, which makes it really nice, and it's a nice packaging system to use those dependencies. And it has an extensive standard library, so it's a great general purpose language. I think it was the Python website as well. It was comparing Python to a whole bunch of other languages. So I put in a couple of stuff here because I know a lot of people like Java, a lot of people like C++ or C#, whatever. And the gist of everything here is that you can do the same work with fewer lines of code. In some cases, it might be a little slower, but it's well made up for in development time. All right, logistics. We will be writing our code in Python 3.8. It is the newest. I don't think 3.9 is general availability yet, but we'll be targeting 3.8. We will not be doing Python 2 because it is officially end of life and it is no longer supported. Python 3.5 is actually being end of life in the very, very near future. So we'll be using Python 3.8. Your homeworks, for the most part, will be submitted via GitHub. GitHub is a public service to store source code. It's a source code management application. I'll talk about that in a couple slides, but you will need a GitHub account for class. Your first assignment, which I think should be popping up now in Canvas as available, is to send me your GitHub link. That is how I will automatically pull down and grade your code throughout the semester, and we will use that everywhere, or I will use that just about every week for assignments. Anaconda is that environment manager for all the operating systems. It'll make life easier if you use Anaconda, I think. When I pause at the end of slides, it's because I just don't want to say any questions again. We already talked about this. I had it right. Visual Studio Code. I didn't provide a link, but you can Google it. It's a Microsoft product. Visual Studio Code. And then we will be using, or you can, as an option, use the Git plugin for Visual Studio Code to connect to GitHub to stash your code. So the first thing I want to cover quickly is what is version control software. If you've heard of Git, or if you've used Git or CVS, or there are lots of others, any other source code control like that, it's a way of storing code, and Git is especially handy because it's built for development teams, so distributed development of an application. We won't do any group projects in this class. You're welcome, but it is the most popular source control version control software in the world right now. So github.com is where we will be using to create accounts and create our repositories. The gist of it is you create a repository, which you can think of as a project or a group of projects. And in that repository, you put your code. So if I'm a command line person, so you'll see a lot of command line references in here, but you can do the same things through Visual Studio Code as well. It's just graphical that way. So you create a GitHub repository, and then you clone it. So the master repository is out at github.com, and you clone it to your local development environment. You do your work, you make changes, then you add and commit those changes. And when you're done committing, you push them back to that master repository. And so when you, every time you make changes, you always want to push it back. If you are in a distributed development environment, you would always, there's another command called pull where you're pulling the latest changes. But since you're going to be working on your own stuff, we don't really have to worry about that too much. I also go quickly on this kind of things because the slides are available, the video will be available. If you need to go back on this, you're welcome to, or interrupt me now with questions. Python, Anaconda, Visual Studio Code. If you have not gotten Python working yet, there is an online compiler for Python. It looks like this, where you can type your Python code in the editor and you can hit run and it'll do what it does at the bottom. You can download the files, all that kind of stuff. Please get it working locally, but until you do, or if you just want to play around, feel free to use this online compiler. It's pretty great. I will probably use this for in-class coding examples just because it's one window I can share and I can just tab back and forth between this and the slides. All right, to some code. So what does a Python program look like? Before I do this, has everyone's done C# development, right? Anybody done Java or C, or I saw a hand for Java, some maybes. So I'm going to try not to just compare everything in Python to Java or C++, but I might fall into that habit. So I'll try not to, because we're learning something new. All right, so the basic parts of a Python program, they always start with imports. Imports are those external libraries or modules within the standard library that we're going to use. So in this case, you'll see I'm importing a logging framework. I'm importing a JSON package. They're both packages. A JSON package. We don't have to worry about what they do right now, but importing is how you get that functionality into your program. There's a global space where you can write code. So you can see this line of code, it's not in a function, it's not in a block, it's just kind of there. This is kind of the global space. So it's how you set up global variables. This is how you set up anything that has, it's package specific. We'll get into that details. But there's this global space you can write code. You can define functions here. And then this is where we'll make a comparison. If you've done Java, you have a main function. C, C++, they have a main function. Python doesn't really have a name function. The standard is you put this code in the global space, but it's really an if block, looking at name and a magic variable, underscore, underscore, that's 2 underscores, name, underscore, underscore, equals, underscore, underscore, main, underscore. This is basically how you make a main method. And so we're going to talk about why you do that, because there are really cool reasons to do it. And frankly, it's going to make my life a heck of a lot easier in doing grading for this class over C++. But just know that's, when we get to it more, that's your main method. We create variables, we call functions, we call other functions. So this is kind of what a block of code looks like. All right, so going through this, now that I want to jump into it a little bit more, and I'll tell you why. Those import lines, the one I want to point out the most is logging. So has everybody written a hello world program? Like The first thing you write in any programming class is print hello world, system.out.println, hello world, whatever, however you do that in your language. I hate that example because it gets developers in a bad habit. It gets us in the habit of using that print statement to debug our applications. And that's a bad practice. So what I'm trying to do here is show how to use a proper logging framework to output debug kind of messages. So we'll be doing that a lot this semester, and we'll talk about why, besides the bad habit. So the logging framework, like any logging framework in any language, you typically have different log levels: debug, info, warning, error, critical. You can think of those like a hierarchy, right? As a developer, you can write a million debug statements to say the value of this variable at this point in time is whatever. And when you run your programs, you'll typically turn off that debug level. And you'll say, okay, when I run it in production, I only want to see warning or above. So you think about debug being the lowest value, critical being the highest value. JSON is JavaScript object notation. It's a way of transferring data, much like you could do with a comma-separated value file or a text file. JSON is a structured way of exchanging data between systems, and we're going to use that heavily. It's irrelevant now, besides that's how you import it. This in Python is how you create that logger. So you always have a logger kind of package or object or something where you can set what the messages are going to look like when they come out, and at what level this logger will allow those messages to come out. So if we set our logging level to info, it would suppress the debug messages. We create functions with this def keyword. So we are defining a function. This function's name is print things as JSON. It has a parameter called thing. It is a required parameter for this function. And all it does is it prints out the JSON version of thing. Don't worry about JSON yet, but that's what it does. So it'll take a object or anything in Python and transform it into JSON and print it out to the standard out of the application. And I already talked about the main function. We're going to talk about a bunch of different data structures. For now, this one is called a dict, D-I-C-T, dictionary. It's a key value structure, but don't worry about it yet. Calling that function, passing in that dictionary, and then we do a log debug message. This should be my hello world. Everybody, does the syntax feel okay? Like, if you've done any other language, it's kind of making sense that you can correlate it to what you already know. I see chat stuff. Anybody want to translate for me?
Makes sense.
Cool. I like the positives, but I like negatives too. So if you ever need clarity, we'll hit it again. When we run... Oh, there's another?
I don't know if you had already answered it, but a person posted, off-topic question, will the skills we will learn in Python translate similarly to R? I see Python and R grouped together often in job descriptions.
Yeah, so R is a programming language of its own. R is used heavily in statistics and data analysis. You can embed R within Python. There are R libraries in order. There are R libraries, R, capital R if you're not familiar, to execute R from Python. And I think we may or may not do that this semester, but they're not the same. But yes, they're very, very similar. They go hand in hand. That's the right way of saying it. All right, so when I run, I use the Python command. I'm explicitly saying Python 3, and then I'm passing in the name of that file with the code in it. So all the code up there is in a file first.py. Python files always end in .py, and this is the output. So that first print of the dictionary is in JSON format, comes out like this. So you'll see the key is high, the value is mom. If I go back up here, you'll see the key is high, the value is mom. And then I have my debug statement, debug completed, called by logging.debug with the message completed. So that debug statement at front, I'm flipping back and forth a lot, sorry, comes from this level name, because the log level of that message was debug. So the debug colon came from this formatter, the log formatter. I think I already covered some of this, but anyway, strings in Python. There's a lot of like things I need to tell you ahead of time, and then we'll really get into it later. So it's kind of a teaser and then more detail later. Python strings can be surrounded by double quotes or single quotes. The main function is that if statement. Print sends data to the standard output of an application. I know for sure on a Unix-based system, every program has a standard output, a standard input, and a standard error. These are streams of exchanging data. So if you are running a command line application and it's printing things to your screen, that is the standard output. When you're typing things to go into that program interactively, that's your standard input. Standard error is used for error tracking, for error messages usually. We'll get, again, I'm going to stop saying this. We'll get into more detail in that later, but just high level, print sends data to the standard output. Don't use print for debug type statements. It's a very bad habit that people can never get out of. People being me. I print everything, but don't. I'm going to teach you from the beginning not to do that. So always use your logging framework. I wanted to give a real, like, what's the word I'm looking for? A functional basic program with that example. But if you do want to see a hello world program, that's how you do a hello world program. Print hello world. And if you want to put it in a main function, there's your hello world. See? But anyway, but don't do that. Spaces or tabs. Anybody watch, what's this? Shoot, now my brain turned off. Silicon Valley on HBO. Early season 1, there's a tabs versus spaces argument between two of the guys. Anyway. We don't use braces, like the curly brackets, before and after blocks of code like we do in Java, C++, etc. Python programs are organized with white space. So if you look at this code here, not important what's going on, but at the beginning we have a function definition. We'll call this indent level 0. The code in that function starts at indent level 1. Right, it's indented into in the text. What is here should be 4 spaces. That is not a mandate. That is a best practice. The official Python formatting guides say to use spaces. Do not use a tab. So if you hit the tab key, it's a different character. That's the spaces versus tabs debate. For this class, we will use 4 spaces. If you don't, your programs won't work. So just continuing down into the code more, you can see you can have multiple levels of indentation depending on what's happening in your code. So I made up a quick example here at the bottom that indents a whole bunch of different levels, but each of those indentations is done by 4 spaces. Are we going fast? Are we going slow? Shrug. I can only see a couple of you, so I'll only see the same reactions. But there are 28. Good pace?
Also, yeah.
Okay. All right. Oh, I can see somebody new. Hi, Caitlin. Um, so every programming language in the universe has variables. Variables are how we store data. The book used the word label, which I really actually like. So the variable, you can think of the variable name as a label. It is a label on how we store some data. Whatever that data may be, we store it in a variable. Python has some naming conventions and rules. Names can only hold letters, numbers, and underscores. Spaces are not allowed in a variable name. You obviously can't use Python keywords for your variable name. Variables must be declared before they're accessed. So if you try to read the value of a variable before you have declared that variable, it's not going to work. Variables can be assigned a value when they're being declared. Standards, like best practices, variable names should be lowercase, all lowercase, with words separated by underscores to improve readability. That goes for function names and for variables. So flipping back a couple slides, one slide, you'll see I defined this function as some function, 2 words, all lowercase, separated by an underscore. That is the PEP 8 is the what do they call it? It's the formatting guidelines. Tabs or spaces. That's one. Yeah, the style guide for Python code. This is like the official style guide written by the dude who made Python. Guido van Rossum is the guy who made Python. Funny story. A buddy of mine used to work at Google, and when you work at Google, you have to go through like a coding test to make sure your code is up to standard and all that kind of stuff. Guido gave my buddy his test. It was kind of funny. 6 degrees of Kevin Bacon, right? That's like nerd. Well, anyway. All right. This is a big important topic. So if you're half asleep, wake up. This is real quick, but it's important. So I said I wasn't going to compare languages, but here I go making a slide comparing languages. Python is what we call a dynamically typed language. You don't specify the data type of your variable when you declare it. So if we looked at C++, we have a variable x. Its data type is int. That means it can only ever store an integer. This data type is an array of characters. It can only store an array of characters. I don't know what would happen if you tried to assign a number to an array of characters, but you wouldn't like the results. But in Python, we don't type our variables, so they can be any value. I can assign an integer to a variable. I can assign a string to my variable. And then the next line of code, I can assign an integer to my variable, the same string variable. There are goods and bads about that. The bad part is you can't hit compile and find an error very quickly. The good part is you can build functions that are a heck of a lot more flexible. So it's something we as developers have to be careful of. And when we're building our code, there are a lot of things we'll do to make sure we're keeping the scope of our variables small so they aren't misused. We'll follow proper scoping rules so variable names don't leak out of where we expect them to be and stuff. But the purpose of this is to say it's all dynamically typed. Everyone get what that means? Thumb nods. All right. Since I literally can only see 3 of you, I won't tell the 3 of you, besides Caitlin, which ones I can see. Sometimes I need verbal. That would help me. So, I heard of something. Was that a yes?
Yes.
Awesome. Okay. Variable types. We have strings. We have floats. These are like our basic data, like what's the word, scalar data types or something like that. The basic things. So strings hold string data. Floats are decimal pointed numbers. Integers are integers. There are no constant type things in Python. Most languages you can set a label that can't have the value changed. In Python you cannot do that. There's no such thing as a final or a static final or a constant value. So the practice is, in this case, you capitalize every letter of your variable. And that should tell the other folks reading, looking at your code that this is not intended to change. You use that for things like pi, that is a universally known thing and never changes. Pi yesterday is the same as pi today, is the same as pi tomorrow. That's where we use constants in our code. Comments in Python are preceded with a hashtag, $, if you're over 40 like me. All comments in Python are single line comments. There are no block comments like there are in other languages. But when you see this, you know that the $, is a commented outline of code, or just a code comment. In this case, the first and the fourth line of code are comments. The two in the middle do things. All right, strings. Now we're going to show you how to make some strings. So on one of the early slides, I said strings can be in single quotes or double quotes. So as an example, this first line of code is creating a variable with the name first string, and assigning the value, this is a string, period. You'll note that the string is surrounded by double quotes. Easy? Easy. The second line, second _string equals, this is a string too. Single quotes. Cool. You can surround it with single quotes. In the third line, the third string, if you want to embed a double quote within a double quote surrounded string, you just escape it with a backslash. So if I printed that out, that line of that code would show this is how to embed a double quote within a string. You cannot start with a double quote and finish with a single quote, or vice versa. It has to match. And for fun, there's a function called len, length. This goes to the dynamically typing stuff of Python. Len can be used on all kinds of data types. In this case, it's going to return to me the length of this string. So a string is technically an array, or it's a list of characters. And we'll get more into that when we talk about lists in general. But it is a sequence of characters. So the len function tells you how many characters you have in that sequence. It's the size of the string can change. You know, it's not a fixed amount of space. We have some functions to manipulate strings. Upper, lower, title. You'll see I'm trying to be super organized in this class, so I'm following the book pretty closely so far. So if you are in the book, I may have my own like code examples, but I'm following what's going on here. Anyway, upper, lower, and title do different things to the string. So if I declared this string as cat in the hat, you'll notice it's all lowercase. I can call the upper function on that string variable, and it returns the string in all uppercase, just like it says. Lower does the same, but in reverse, it lowercases all the letters. I didn't know this existed until I looked at the book yesterday. There's a title function, which will capitalize the first letter of every word. Kind of cool. You'll see the way I'm showing this code is different than I was before. So these like three greater than signs are because I ran Python 3, just the word Python 3 from my terminal, And it kind of gives you this interactive Python environment. So I can do things like create a variable, and then if I just do like the variable name, the next line it'll give me that value. So if I do string.upper, it'll just show me that value. I don't have to assign it to a variable and then log out that variable. So just something to play around with. Tabs, new lines, any other either printable or non-printable characters you can embed within your Python strings. So here I am embedding a new line character. So this I thought was kind of neat. In that interactive environment, when I typed in just a variable name, it showed me that the actual value in that string, which is kind of cool. But when I printed it using the print function, it actually put a new line character out. That was kind of neat. But anyway, you can do new lines, you can do tabs, you can do as many of them in there as you want to. So you'll see when I have the tabs in here, I printed it out and I got tabs between those words. Is anyone familiar with the ASCII chart, like what the ASCII numbers are, values are? Anybody familiar with what ASCII is at all? Okay, cool. Let's do a quick Google ASCII chart. So ASCII is the American Standard Code for Information Interchange. This was way more important when we were doing C++. The only reason I'm showing it to you now is because it's important to know that there are more characters than just the ones you're familiar with. So we're all familiar with exclamation points, the number 3, the number Q, etc. But there are others. There are things like, let's find the new line character. There's a space up there, and a medium, carriage return. So there are a whole bunch of other characters in here. A horizontal tab, backspace. You can embed all of these into your Python strings. It's kind of neat. But that's way less important in this class than it is in C++. So that's just old habits to show you that. But everybody's familiar with new lines and tabs, right? Head nod. Head nod. All right, cool. Stripping. Appropriately. Removing white space before or after a string. So in this case, we have a function, or we have a variable str with that as the value. A whole bunch of spaces at the front, a whole bunch of space at the back. The string class has a L strip, left strip, right strip, and a strip. Left strip removes all the white space at the front. English left to right, so left is front in my head. If it's not in yours, I'm sorry for generalizing. Left strip removes from the left, right strip removes from the right, strip removes both left and right. So you can see what that does in the code example. So with that string with spaces at the front and the back, if I L strip, if I left strip, it gets rid of those white space at the beginning. If I right strip, it removes the white space at the end. And if I strip, it takes all the white space out from the front and the back, but not the middle. Only front and back, not the middle. That's important. I'm glad I said that and didn't write it down. I tend to do quizzes weekly. You're welcome. They will be short. They are not meant to trick you. They're just meant to kind of make sure you paid a little bit of attention. And so, as an example, I would probably throw in these strip functions into those quizzes somehow, and you got to tell me L strip removes from the left, just as a way I teach. I didn't talk about the grading, but I do regular quizzes. I do regular coding, like almost weekly for the coding, almost weekly for the quizzes. We'll do a midterm and a final. We don't do like a big cumulative project or anything like that. So it's more week to week as opposed to an ongoing thing.
Would the quizzes be at the beginning of class?
Yes, they would be. Yep. But because of COVID, because of the way life is now, I'm going to be a lot more forgiving when it comes to that. So, as an example, if you have to be late for class, I will typically leave the quizzes open. Let me think. What do I want to do? Quizzes I'll probably leave open for 24 hours.
And will they be? Oh, sorry.
No, go ahead.
Will the quizzes be like short answer, fill in the blanks?
All of the above. Short answer, matching, multiple choice, whatever Canvas does that allows me to have it automatically graded, usually. Cool. People get all worked up about quizzes, but mine are pretty easy. So this is my favoriteest thing that they added to Python recently. It's called a formatted string. In the book, they call it using variable strings on page 29. So let me show you why I love this. The old way of doing formatting of strings, say I have a first and a last name, or a name and a last variable, and I want to combine them into a single string. I would do this funny looking thing where I have a placeholder, a space, and a placeholder. Then I call this format function, passing in name and last. The output, the end result, will be Chris Fauerbach. Okay, makes sense? What they've done now is if you put an F in front of the string, you can put the variable names inside those placeholders, and it just works. So it's not a huge line of code saving or anything, but to me it makes a lot more sense because now I can see where the placeholder is, what value is going to go into it. Where before, imagine I had 14 of these because I'm making a comma separated file. If I had 14 placeholders and then a list of 14 variables on the right, that could get confusing. And so now I can just do it all like this. And I can even go do functions within here. It's just, it's so much nicer. So I love formatted strings. We'll use them a lot. Does that make sense? I know that was a super quick overview and probably not as exciting as I want it to be, but I'm really excited about formatted strings. But the magic letter is that F in front of the string definition. When I highlight things like that, y'all can see that, right? Like the highlighted that little F. Okay, cool.
Yes, we can see that.
Perfect. Substrings, no, we're not going to do that. Because this is different. I mentioned earlier about strings being character arrays and stuff like other languages. There are some really neat tricks you can do with treating strings as an array. And so we'll get into that next week. Man, I'm going through this way faster than I thought I would. Am I like an awesome teacher or is this super basic? Or both?
You're awesome. You're an awesome teacher. That's definitely what it is.
All right, Amanda, thank you. I'll write that down. No, I'm just kidding. Thank you. All right. But no, this is good because now it'll tell me how much content to put in every week. So, and I also don't want to keep everybody here till 9:40 because 9:40 is late. But y'all are paying to be here till 9:40. So if you want to be here till 9:40, we will be. But nobody wants to be here till 9:40. But we will be if we have to. All right. Anyway, numbers. So we mentioned earlier that I keep saying we. I mentioned earlier that we have basically two types of numbers. We have floats and we have integers. There are ways to cast the data types. So if I start with an x variable as 3.14 as a float, there's an int function. It's kind of a high-level, top-level function. You don't have to give a package or anything. It's just a function that works. I'm casting x to an integer. Technically, there's a function called int that I'm passing the float into, and the return value is an integer. So it is actually very different than casting in other languages. But then I print out x, and you can see it hasn't changed. It's still a float, but y is an integer. Then if I call the float function, passing in an integer, it returns a float, and the value of that float is 3.0. It's not 3. It's not the integer 3. It is the float 3.0. Puzzled?
It makes sense, but so is it always going to round down to the integer and just drop everything?
Awesome question. Yes, it's flooring the number. It's technically truncating everything after the integer. So it's not rounding. That's what I'm trying to say. So if it was 3.7, it would not round it to 4. It would floor it to 3. And I said that, but now I'm going to test that. What the? Don't do that. Please be right. Okay, I was right. Good. I don't know if you can see that because it's kind of small. But yeah, it did not round. It floored. We can do math within Python. Surprise, surprise. We can add two numbers together. We can subtract numbers. We can multiply numbers, and we can divide numbers. This one I thought was interesting. The divide. Why am I saying that's interesting? Anybody want to guess? Two plus 2 equals 4. Totally makes sense to me. 2 minus 0 equals 2. Totally makes sense to me. 2 times 2 is 4. Makes sense to me. 2 divided by 2 is 1. Did somebody answer in the chat?
They just said float.
Float. It returned a float. I find that interesting. It did what it did. We can do shortcuts of how we can add two numbers together. So instead of doing x equals x plus 3, we can do x plus equals 3. Same thing with all the other operators. X minus equals 2. Instead of x equals x minus 2. The cool part about this, we're going to cover like all the syntax today. Next week, we'll start doing real stuff. That's why I'm excited about Python. I did not know this until I read the book last night. We can do exponents in a nice shortcut kind of way. So the first one, 4 raised to the power of 2. 4 raised to the power of 3. And those can be variables. Anywhere I have a number in here, like a 4 or 2, etc., you can do variables as well. So the last one, I have x equals 3, and then I'm raising x to the power of 2. The 2 could be a variable as well. You could raise x to the power of y. So depending on what's happening in your code, it'll evaluate the same. Modulus, you'll see in every other language as well. It gives you the remainder of a division operation. So in this example, x equals 13, x modulus 2, or y equals x modulus 2, the value of y equals 1. Because 13 modulus 2, so 13 divided by 2 is 6 with a remainder of 1. So the remainder is what's returned. 13 modulus 5 is 2 with a remainder of 3. So let me say it again. 13 divided by 5 is 2 with a remainder of 3. So the modulus operator gives you the remainder. I think C#'s the same. Maybe, probably. I know it is in Java, in C, C++. I think it's C# too. It's been probably 10 years since I've done any C#. Multiple assignments. So all the variables we've assigned have been like x equals 3, x equals y, whatever. In Python, you can assign multiple variables, different values on the same line. So the first one, I'm declaring and assigning the variables a, b, and c with the values 1, 2, and 3. So on the left is the variables, on the right is the things being assigned to them. Makes sense. Here, they don't have to be the same data type as I'm showing down here. So the first one's an integer, the second one's a string, the third one's a float. It doesn't matter. Now, in your code, you really won't do this. You would probably never have a line of code that looks like either of these. What you may do, though, is you may have a function that returns multiple values. And so you would have the function definition, and from a function you can return a list of values like this. As an example, jumping over to our Cody code, let's say I had a function, return some values, return 1, 2, 3. If A, B, C equals return some values, print A. See, I'm breaking my rule here because it's faster. And if I print them all out, I should get 1, 2, and 3. So my function is returning 3 values. You don't declare a return type of a function in Python either. Like we don't declare the type of I see, is it too small? Is that a little better? Cool. We don't declare a return type on our function, nor do we define the types of the parameters to a function. I already said that. And so here I can return whatever I want. One of the weird things about Python, I could do a block of code, and here I could return 1 value, none, which is the same as null or no value. But in this case, I could return 3 values. So there's some trickiness that comes as part of that untyped language. So best practice is you wouldn't do this because you know somebody's going to be assigning it to 3 variables. So you'd probably return none, none, none. Which I didn't put none in my slides today, which I should have. None is the same as null. It means no value. It's not the same as 0. It's not the same as an empty string. It is nothing. Okay. I think that's it of importance. Any questions on that? We rolled through 38 slides really, really quickly, even with my ranting about the honor code for like 10 minutes.
Question posted. These slides are posted online or no?
Yes, they are. I will share this link in Canvas, but it's chrisfauerbach.github.io/info450_fall_2020. I will actually post them in the Slack chat or Zoom chat as well. And they're stored in GitHub like your code's going to be, and so I update it regularly. Where's my chat?
Also, when will videos be posted?
Probably within 24 hours. Probably tonight. Actually, I'm going to stop recording there.